Hello all, welcome to Code Hub. Consistency is the key to success, and today come let's solve the LeetCode daily challenge. And the question is the maximum erasure value. The question states that you are given an array of positive integers nums and want to erase a subarray containing unique elements. The score you get by erasing the subarray is equal to the sum of its elements. And we have to return the maximum score you can get by erasing exactly one subarray. That is we have to erase exactly one subarray so that we can get a maximum score. An array B is called to be a subarray A if it forms a contiguous subsequence A that is if it is equal to A of L. This is we know that the subarray is a contiguous thing. Okay, we can take some example and see 4, 2, 4, 5 and 6. And they have given the most optimal since it is containing the only positive integers. If the array contains a distinct integers, then the whole sum will be our answer, will be our maximum score. But if it does not contain distinct unique elements, then we have to find some unique subarray such that we will get the maximum score. So for this array, the maximum score is 2, 4, 5, 6. As you can see here, the subarray 2, 4, 5, 6 contains only unique elements. 2 plus 4 plus 5 plus 6, which is 17, and this is our maximum score. Okay, come we can think of some brute force approach. For brute force approach, what we can do is we can run a for loop where it ranges from 0 to n. N will be the size of the array, and we can run another for loop from I to j. That is, we can consider a j pointer. We can consider it runs from I to n, and we have to see whether the subarray from I to j contains only unique elements. If all the elements contains unique elements, all the elements are unique. If all the elements are unique in subarray I to j, then we can add it. Then sum equal to add elements from I to j, and we can update our maximum score. Max of max score comma sum. By this we can do this problem here. This is our brute force approach, but what is our time complexity here? It will be order of n cube, right? Order of n cube. And what is our space complexity here? We are using only a sum variable, so it is order of 1. But we have to check whether it is unique or not, so we will declare a set here, and we will insert all elements inside the set, and we can proceed further. If the elements are seen in the set, then we cannot take that subarray. So here it will be order of n, where we will store the elements in our set to check whether it is unique or not. So this is our time and space complexity. But how can we optimize this solution? Optimized, let us see. We can use a sliding window technique here. How I am saying is, we can take the same example 4, 2, 4, 5, 6. Here first we can consider I pointer and j pointer is here. We can say it as start and end. We can add an element into our set, and we can add the sum also. We can add the current element to our sum. Consider we have a set. This is our set. This is a set. We can add the element where the end pointer is pointing. We can add it that element to our set, and we can add it to our sum also, and we can move our end pointer, and we want to check whether this 2 is present already in the set. If it is not present, we can add the 2 to our set, and we can add 2 to our sum also, sum as well, and we can move our end pointer again. And you can see that we have to maintain only unique elements inside the subarray. So we can, when we are encountering another 4 which is inside our set, so we can just contract our window, and we can proceed further. So this maximum score is updated to 6. We will have a maximum score also. Maximum score will be 6 as of now, and we can contract the window. Now we will contract our window. When we contract our window, this obviously this 4 should be erased from our set. So we will move our start pointer, and the 4 is erased from our set. And obviously we have to subtract the 4 from our running sum. So we will subtract it, right? And then now we have to insert the element which is at the end, and 4 is inserted to our set, and we will add 4 to our sum. 4 plus 2, which is 6, and we will update our max score. Next, again we will move to our end pointer, and 5 is added to our, since 5 is not inside our set, 5 is added to our set, and 5 is added to our running sum as well. So it is 15, and our max score is updated to, sorry, it is sum is 11, and our max score is updated to 11. And again we have to expand our window, and 6 is not present in our set, so 6 is added to our set, and then we have to add to our running sum as well. It is 17, and our max score is obviously updated, and we'll get our max score as 17, and it is our optimal answer. So what will be the time complexity for this technique? We are using just a sliding window technique. It is very simple by using a set. So the time complexity will be order of n, since we are traversing only once the whole array, and the space complexity will be order of n, since we will be storing at max n elements to our set. If all the elements are distinct, we will be storing all the elements in our set. So this will be the most optimized approach, and here the constraint is 10 power 5, so obviously 10 power 9, 10 power order of n will work. So we will just code the approach here now. We will copy this for our reference inside our comment, and we will make as comment. Okay, yeah. Okay, now what we are doing here, we should have a start pointer and an end pointer. In start, which is starting from 0, and end, which is starting from 0, and we should have a length of the array. N is nums dot size, and here while end is less than n, we are going to run our loop, and end plus plus for next iteration. And we should also have a set. We will declare an unordered set of integer of type integer st, and this is going to store our elements into our set. And then we have to check whether the element is not present in our set. We should check whether st dot find of the element nums of end is not present. St dot end. This condition, this syntax will check whether the element is present in the set or not. If we make equal to st dot end, then it will check whether it is not present. It is present or not. Okay. If the element is present already in the set, then we have to erase that element from this set. Nums dot since we are contracting the window, we will be erasing the element which is at the start position. After which we also have a running sum, right? We have to decrement the running decrement with the nums of start. After which we will increment start plus plus. Yeah. So we want a running sum as well. We will declare the sum to be 0. After which what we are doing, we are inserting the current element to our set. st dot insert of nums of end. After inserting, we are also adding the sum to our sum variable. So adding the element to our sum variable end. Fine. After this, we are update. We need a maximum score, so we will have a maximum score variable which is going to give me update the maximum score and sum. After which finally we will return the max score, and we will declare max score to be 0 initially. Hope this will run. What we are doing here, first we are traversing the entire array, and until the current element is not in our set, we will just erase the element which is at the beginning, and we will decrement with this sum as well. Since we are eliminating the array, since we are adding the current element to our set, we must maintain the unique elements in our set, right? So we are eliminating the elements which are at the start position. We are just contracting the window here, and then we will decrement the start. After coming out of this while loop, we will insert the element into our set, and then we will add to our running sum, and we will update the max score, and finally we will return the max score. Hope this will run. Let's see. Yeah, it is running smoothly. We can use example test cases as well. Yeah, it gives correct answer. Okay, let us submit and see. Here the time complexity will be order of n and space complexity will be order of n. Yeah, we got accepted. That's good. Okay, see you in the next video tomorrow. Until then, bye. Thanks for watching.